Okay, so this is a problem based on Newton's laws of motion. Specifically, we are going to use Newton's second law, which is more commonly written as the net force equals mass times acceleration. So, before doing the problem, let's read the question. The horizontal surface on which the block of mass 1.8 kilograms slides is frictionless. So that means we can ignore any sort of friction forces between the block and the surface. The force of 49 newtons acts on the block in a horizontal direction. So that's the force to the left, and the force of 147 newtons acts on the block at an angle as shown below. So this is the 147 Newton force. You can see it's at an angle making 60 degrees with the horizontal direction. So the question is, what is the magnitude of the resulting acceleration of the block? The acceleration of gravity is 9.8 meters per second squared. So they are just asking for the magnitude or the size of the acceleration. You should know by now that acceleration is a vector quantity. So in order to fully describe acceleration, we need to give its magnitude as well as its direction. So in this case, we are just going to give the magnitude of the acceleration. So the first thing I'm going to do with these sort of problems is define an appropriate XY coordinate system. Basically you have to define your direction. So a coordinate system is going to help us to do that. So I'm going to use our regular XY coordinate system. That is, the X direction is to the right, that's the positive X direction, and up would be the positive Y direction. Okay, so that's my XY coordinate system. The next step is to draw the free body diagram for the 5.8 kilogram mass. The free body diagram will include all the forces acting on that object. Okay, so free body diagram for 5.8 kilogram. Okay, that's the next step. So here I'm going to replace that mass by a dot and then draw all the forces acting on that object. So you can see very clearly there's mass. So that means there's a weight acting on the object. Let's call it mg. Okay. And then since it's in touch with the horizontal surface, there's going to be a vertical force acting on the system. And that's what we call a vertical reaction force. And that's what we call the normal force. So the normal force is in this direction, F subscript n. And then there's a 49 Newton force to the right. So I'm going to draw that force like that. That's 49 Newtons. And then there's this 147 Newton force at an angle with the x direction. So like that. That's the direction for the 147 force, 147 newtons, and that makes an angle of 60 degrees with the positive x-axis. Now remember that the size of the vectors, their angles are not to scale. Okay, so just keep that in mind, they are not to scale. So this completes the free body diagram for the 5.8 kilogram mass. Now they are asking for an acceleration. So if a net force is acting on an object, if the net force is non-zero, then the object is going to have an acceleration according to Newton's second law. The important thing there is the direction of the net force is the same as the direction of the acceleration. So now I'm going to I'm going to assume that this is the direction of acceleration of the object. That's the direction of acceleration. So I'm putting an arrow on top to signify that it's a vector quantity. So I have defined my direction of acceleration. I have drawn the free body diagram. Now I'm going to apply Newton's second law in the direction of acceleration to that object. Okay, so now I'll write F net is equal to mass times acceleration for 5.8 kilogram mass in the x direction, okay, in the x direction. So you can see, because I am specifying the direction, this F net equals ma equation becomes a scalar equation. Otherwise it's a vector equation. Since I have specifically defined a direction, now the equation can be considered as a scalar equation, just magnitudes, okay. So now what I'm going to do is that I'm going to find all the forces acting on the 5.8 kilogram mass along the x direction. So that's going to be my net force, right? So let's look at the net force. So I have 49 newtons, that is in the positive direction. Mg, that is vertical. There's no component for the x direction. Fn, that is also vertical. There's no component along the x direction. But when we consider 147 newtons, we can see there's this adjacent angle, right? 60. So as a result, there's going to be a component to the left from the 147 Newton force. As a result, I'm going to put minus 147 times that adjacent side component, which is going to be the cosine of that angle. And then this is equal to the mass of the object, which is 5.8, and times the acceleration. So we can find the acceleration here. So if we substitute the values for the acceleration, then what we are going to get is 49 minus 147 cosine 60 divided by 5.8. If you solve this, simplify this, you are going to get the acceleration is negative 4.2 meters per second squared. So what does the negative sign tells you? The negative sign tells you that the actual direction of the acceleration is going to be to the left. Here you can see we have assumed at the very beginning that the acceleration is to the right. But when we substitute, we get acceleration as a negative value. So that means our original uh, assumption for the direction is wrong. It has to be the opposite direction. Okay. So this means, I'll write it, this means the acceleration is actually along the negative x direction. It's not along the positive x direction, but it's along the negative x direction. Now the question is asking for the magnitude. So the magnitude of the acceleration is just, they're asking for the size without any sign. So that means 4.2 meters per second squared up to 2 sig figs. So that's going to be the acceleration. Okay, so that's how you do that problem. Now there's a connected problem apart for this apart for this question is how do we find the normal force? Like that's also something important. How do we find the normal force? So let's try to do that. How do we find Fn, the normal force acting on this 5.8 kilogram mass? So again, we can apply Newton's second law, but this time along the y direction. So let's do that. So F net equals mass times acceleration along the y direction for the 5.8 kilogram mass. Okay, so we are going to apply it along the y direction. So you can see then how do we find the net force? You can see Fn is in the positive y direction. Weight, you can see that's in the negative y direction. So I'm going to write minus mg. And then there's a component of that 147 newtons. Again, it's pointing downward. So we have minus 147 sine 60 degrees. And this is equal to mass times acceleration. Mass is 5.8 kilograms. But what is the acceleration of this object in the y direction? you can see the object is constrained to move along the horizontal surface. That means it's going to have an acceleration in the x direction, which we calculated in the previous part. But there's no acceleration in the y direction. So as a result, I can write 5.8 times 0, because there's no acceleration in the y direction. It has no motion up or down. It's just constrained to move along the x or the horizontal direction. So as a result, we can find Fn equals, I'll substitute for mass and g, that is 5.8 times 9.8 minus 147. So that if you take the mg and the other term to the right hand side, this is going to be a positive, okay? Sine 60, and then you should get your answer as 184 newtons. But if you want to keep it in terms of 2 sig figs, then I would write 180 newtons as the magnitude of the force. Okay, so this is, I'll write 2 sig figs, 2 sig figs, and this is also 2 sig figs, 2 sig figs, up to 2 sig figs. This 184 is 3 sig figs, okay? That is 3 sig figs. Remember that. And this gives you the magnitude of the force. But if someone asks you what is the direction of the force, the normal force, you can obviously see it's pointing in the positive y direction. So it's upward according to this figure. It's 180 newtons up to 2 sig figs, pointing upward along the positive y direction. So this is how you do this problem.